Cubic functions, grade 12 mathematics, paper 1. So we are looking at how to determine the equation of a cubic functions when given the coordinates of the turning point. These are very common questions that we meet in these exams. So what happens is you are given an equation, but the equation is not complete. Like in this case, I've got the equation of the function, but the equation is missing two numbers. I need P and I need Q. So the first question for me is to prove that P is equal to -5 and Q is equal to -4. How do you answer this kind of questions? So the first one is to determine the values of P and Q. You must create simultaneous equations. And those simultaneous equations are created in two ways. You substitute. So you're going to substitute X and Y with the coordinates of the turning point. The coordinates of the turning point here are 2 and -9. So you substitute X and Y with the coordinates 2 and -9, and that calculation is going to give you one equation that contains P and Q. Then after that, number 2, you differentiate. So written in short, we can say you substitute X with 2. You substitute X with 2 in the derivative when it's equal to 0, because at the turning point the derivative is equal to 0. This will give you another equation which we can call equation 2. Then equation 1 and equation 2, you must solve them simultaneously. That is how to answer number 1. Number 2, you are given a point and you need to calculate the coordinates of B and C. B and C, these 2 points here, these are the x-intercepts of the function. And to determine the x-intercept of the function, y must equal to 0. So that means we must equate the equation to 0 and solve for x. That will require factorization of the cubic function. And factorization may need you to use the long division or the factor theorem or a synthetic method. Any method that you are comfortable with is what is required in question 2. We need to factorize it. In question 3, determine the coordinates of D, which is the local maximum. So at the turning point, we know that the derivative of the function is equal to 0. So to answer the third question, we differentiate the equation. After differentiating the equation, we equate the derivative to 0 and solve for x. These are the 3 concepts that are being tested by this question. We need to understand how to answer this kind of questions for examination purposes, because this is something that we may expect. So now that we have had a breakdown of the ideas that we want to use, we can go ahead and answer the question and see how to do the calculations that are supposed to be done here to produce the answers. All right, let's look at how to answer this kind of questions where the equation of the cubic function is not complete and you are given the coordinates of the turning point. So we are given the equation of a cubic function here. The graph is drawn and we don't have a full equation. It's missing some values, but what we have are the coordinates of the turning point. So we have the coordinates of point F, which are 2 and -9. Now, how do we use the coordinates of the turning point to find the missing numbers which are needed in this equation? So here is what we do. We need to remind ourselves, how do we get the coordinates of the turning point? The coordinates of the turning point are found by equating the derivative to 0. You differentiate your function, equate the derivative to 0, and solve for x. That is how we get the value of x for the turning point. So when the turning point has coordinates given, what we do now in this case is that we differentiate the equation and equate the derivative to 0. After equating the derivative to 0, we substitute x with 2 because the x value at the turning point is equal to 2. So that's what I do. So I differentiate the expression, and after differentiating the expression, I equate the derivative to 2. So we can safely say the derivative of this function is equal to 2, is equal to 0 when x is equal to 2. That calculation will give us an equation that we must solve. In this case, the equation will contain P and Q. So we are not able to solve it yet, but we are able to express it in the simplest possible form. So to quickly repeat, we differentiate the equation and equate the derivative to 0. After equating the derivative to 0, we then substitute x with the x value of the turning point. So in this case, after equating the derivative to 0, I substitute x with the 2 because the x value of the turning point is equal to 2. That will give me equation number 1. So right now, I have got one equation in P and Q. Then secondly, the coordinates of the turning point. The first value is x and the second value is y. Just like any other point on the graph, we can substitute these coordinates into the equation of the function. Put 2 in place of x and negative 9 in place of y. Then simplify. That will give us another equation that contains P and Q, or we get another equation in terms of P and Q. Simplify that equation to simplest form. Now you've got equation number 2. Now, we have got two variables, therefore we definitely need two equations, equation 1 and equation 2. The next thing to do now is to solve these two equations simultaneously. Now you have the options of using substitution, of using elimination, whatever method is possible or is more convenient for you, you can use it to solve the equation. So in this case, we're using the method of substitution. So in equation 2, in equation 1, 24 plus 4p plus q is equal to 0. We can simplify this equation. Now this is my equation 1, putting together with equation 2. Then in one of the equations, in this case in the equation 2, we can make q the subject of the formula by moving the 2p to that side. Then we get q is equal to minus 14 minus 2p. Then we take this value of q and substitute it into the first equation in place of q. The point is you solve the two equations simultaneously using any method of your choice. After solving the two equations, we can safely see that p is equal to negative 5 and q is equal to negative 4. We have answered question 1 for 6 marks. So to quickly repeat, when given the coordinates of the turning point, you create two equations in the following way. One, you substitute the coordinates into the equation of the function and simplify. 2, you differentiate the equation, equate the derivative to 0, and substitute the x value with the x value of the turning point. That will give you equation number 2. Then finally, you solve the two equations simultaneously to get the values that are required. This is how we handle this kind of questions when given the coordinates of the turning point. Question 2 and 3. In question 2, we are requested to calculate or to determine the coordinates of B and C. When we look at our graph, we can see that B and C are the x-intercepts of the function. So at the x-intercepts of the function, f of x, which is the equation of the function, must equal to 0. So we need to equate the equation of f of x to 0 and solve for x. From the coordinates of point A, we are given the coordinates of point A. It's -1 and 0. This tells us that the value of x when f of x is equal to 0, x is equal to -1. And if x is equal to -1, it follows that x plus 1 is one of the factors of the expression. So after factorizing it, we must get x plus 1 as one of the factors because x is equal to -1. Now, the method to apply. You apply whatever method that you are comfortable with. Long division, synthetic division, factors, whatever method. There is no limitation as to what method you can use here. In this case, we have applied the method of synthetic division. So just to remind you quickly how synthetic division works. The first number, this one, this -1 here, this is coming from x is equal to 1, the coordinates of point A, which are given as -1, 0. It means x is equal to -1. That is where we get this first one. The other 4 numbers are the coefficients of the expression. So the coefficient of x cubed is 2. The coefficient of x squared is -5. P is -5. The coefficient of q is -4. And the last term, which is the constant, is equal to 3. So these 1, 2, 3, 4 numbers are these ones here: 2, -4, -5, -4, and 3. Those are the answers, the values of the coefficients. Then when we do our synthetic division, these 2, we write it down here. Then we multiply it by the value of x. So it's -1 multiplied by 2. The answer that you get, you write it under the next column. So -1 times 2 gives us -2. Now these two numbers, we add them. -5 minus 2 to get -7. Then you multiply again. -1 times -7 gives a +7. We write the answer in the next column. Then we add these two numbers, writing the answer at the bottom. -4 plus 7 is equal to +3. Then we multiply again. -1 times 3, you get -3. Then we add these two numbers. The answer is equal to 0. We have done our synthetic division. Now we can complete our factorization. The 1, 2, 3 numbers that we have, this one is the value of A, this one is the value of B, and this one is the value of C. So these are constants of a quadratic expression, ax squared plus bx plus c. We have done a video on synthetic division and explain how to factorize cubic functions. You can refer to that one. but I just thought I should remind you here. Now that we have got some values of a, b, c, we now have the quadratic factor of our expression. The first one is x plus 1, which is coming from x is equal to 1, the value that we have been given. Now we need to factorize this part here, this quadratic expression, into 2 more brackets to complete our factorization. Then after that, we want to solve for x to determine the x-intercepts. Therefore, we equate f of x to 0, and that will give us the 3 values that are needed. X is equal to -1, that gives us the coordinates of point A, which we are already given, and x is equal to half, that will be the coordinates of point B, and x is equal to 3, that gives us the coordinates of point C. And that answers question number 2. The third question, we need to remind each other, we are requested to calculate the maximum value or the coordinates of the maximum of the local maximum point. What are the coordinates of the turning point, the stationary point, the local maximum point? They can use any of those terms. Your method: at the turning point, the derivative is always equal to 0. At the turning point, the derivative is always equal to 0. So what do? You differentiate, equate to 0, and solve for x. You differentiate, equate to 0, and solve for x. You differentiate, you equate to 0, and solve for x. That's how we determine the coordinates of the turning point. So get our equation, we differentiate it, the derivative that we get, we equate it to 0 and solve for x. When we equate the derivative to 0, the equation that we produce here is a quadratic equation. Now you need to appreciate the importance of understanding quadratic equations, because if you don't get quadratic equations right, you definitely are bound to lose a lot in an exam, because they are basically everywhere. Now, the quadratic equation can be solved using any method that you are comfortable with. It can be factorization, it can be completing the square, it can be quadratic formula, any method. So mine here can be factorized, therefore it has been solved using factorization. We get x is equal to -1/3, or x is equal to 2. Now this one here, x is equal to 2, this definitely must be the x coordinate of point F, because F is one of the turning points, and the coordinates of point F are already given. It's 2 and -9. So that means we need the coordinates of point D. So definitely we're going to use the x is equal to -1/3. Now we need the y value. The y value in any situation in this case, we calculate it using the original equation, not the derivative, the original equation. In place of x, you put -1/3 and calculate the value of y. So in my case, y is equal to 3.7, and that completes the calculation. The coordinates of point B are -1/3, 3.70. Then we have answered the question. So the main idea to keep in mind is that to find the coordinates of the turning point, we differentiate our equation, equate it to 0, and solve for x. That answers the